Good morning, good afternoon, good evening, wherever you may be calling in from. My name is Joe Dobbins. I'm with AU11, which is the Office of Worker Safety and Health Policy. We'd like to welcome you to our WebEx series 2020. Before we get started, we actually are required to provide an acknowledgement as we are recording this meeting. The Department of Energy requires us to read this with any type of future recording. So if you'll bear with me, I'll read this and then we will begin our presentation. The Department of Energy recording acknowledgement. This WebEx call is being recorded and may be posted on the Department of Energy's website or used internally. If you do not wish to have your voice recorded, please do not speak during this call or disconnect now. If you do not wish to have your image recorded, please turn off your camera or participate only by phone. If you speak during the call or use a video connection, you are presumed to be consent to recording and the use of your voice or image. Question and answers at the end of the presentation will not be recorded. Okay, great. So now that we are through that, our presentation today, we're in for a very double header today. The theme of today's 2020 WebEx is actually about construction safety. The first part is for the use of lasers in the Department of Energy for construction safety. Our first speaker is Mr. Jamie King. He's from the Lawrence Livermore National Laboratories. Our second speaker of the topic is hoisting and rigging. Fall Zone and Danger Zone by Bill Schleyer, who's part of the NNSA. And we have some introductory slides to get to, and then we will introduce our speakers to transition to their discussions. So today's agenda, we're going to discuss some logistics, some AU11 policy updates, some announcements, and then we'll turn it over to our speakers with their respective parts of the discussion. So some information about audio considerations. We will do question and answers at the end of the presentation. It's encouraged for you to use the chat function that's in the lower right-hand part of your screen. You are welcome to unmute yourself. At the end of the call, we ask, and you're welcome to hit *6. That will unmute you. We do request that you stay muted during the duration of the call as we are recording. This is a first time that I've actually attempted to do this with AU11. I believe we've done this in the past, but it's something that we've had many interest with feedback that we've received, and we are gratefully appreciated for our audience to give us opportunities to improve the webinars, as the educational experience is always appreciated. At the end of the WebEx, we will send out a location with the slides that will be available for download. We are working on the uploading of the actual recording. That may take a little bit longer. There's two locations. We may actually house it at the location where the slides will be posted, or there possibly might be another option with Energy.gov. We're still kind of working that out, so that may be delayed, but all the information will be included in the email with the final post. So, a little bit about our office. So we are the Office of Worker Safety and Health Policy. Our director is Mr. Jim Dillard, and the rest of our individuals that are in our group. The two individuals actually we would like to recognize today is Mr. Steve Singal and Mr. Maurice Haygood. They were both instrumental in getting our speakers today, and we'd like to say thanks to them for organizing that effort, and you'll get to hear from those individuals. Actually, Mr. Haygood momentarily. Mr. Singal, unfortunately, will not be able to speak, but that's okay. AU11 policy updates. So some is current work that we're working on. 10 CFR Part 850, which is their Chronic Beryllium Disease Prevention Program. AU11 has received further comments from the Office of General Counsel on that, and the discussions are ongoing regarding progress for 850. Handbook 1163. This has completed the RevCom cycle, and it is pending publication. Just a couple last things that need to go on, and then hopefully it will be published in the short term. So that's exciting news for the update for Handbook 1163. Handbook 1100, it will be submitted to RevCom with a change notice. Hoping to have an update on October 1st. And lastly, our Handbook 1092, which is the DOE Electrical Safety Handbook, is currently under a policy revision, which is preparing for the RevCom process. Should have an update November 1st. So a little bit about just our WebExes and some feedback. We do appreciate everybody who attended the last WebEx in the series that dealt with heat stress. We typically, within our series, occasionally we will have special WebExes, but just as it pertains to the series, we will typically have a feedback survey, and it also allows individuals to request a certificate, actually, for your participation, and that has continuing education units. So those links are on the slide there. We also will include those in the email that we send out once the WebEx is completed. Feedback is anonymous and is encouraged, so if you feel free to have positive or negative feedback. We listen to them all, we take them all very serious, and we appreciate your feedback. Some announcements. In October, we're actually going to have a 3-part series about industrial hygiene exposure monitoring, which is going to be really exciting. Our speakers are still to be determined. We're kind of ironing out a couple of the details on that. But they'll be all on Wednesdays, October 7th, 14th, and 21st. So please watch for that. I believe we did send out invitations as calendar invites, but we probably will send out an additional update to that with the speaker information as we finalize that in the coming weeks. Again, if you have suggestions, feel free to send me an email. My email is right there, joseph.dobbins@headquarters.doe.gov. Lastly, our laser workshop, which was at the University of Texas in Austin, I think had kind of some postponement due to the COVID-19 issues. From what I understand, the different papers will be posted, I think, by the end of September 2020. So those who are involved in the laser community, definitely keep an eye out for that. Great information. Other announcements, the DOE also has a COVID-19 hub. It's Energy.gov COVID-19 Hub that has the latest information about COVID-19, as well as the hotline that continues to be active. A couple of members of our group, Robin Keeler and Carlos Kaufman, are key supporters in that endeavor, so we thank them for that effort. The last slide for our introductory thing is to recognize our FEOSH program. It's about drunk driving. Important, definitely do not do that. Definitely stay sober. The different options when you get a taxi cab or public transportation, spend a night, be aware, take care. So our first presenter his name is Mr. Jamie King, and he comes to us from Lawrence Livermore National Laboratories and has quite a lot of experience in the laser safety community. Jamie, the floor is yours, sir.
Okay, can you hear me?
Yes, sir.
Okay. All right, so I was asked, my name is Jamie King again. I'm from Livermore. I serve on a lot of different communities. Main one here for our group is the FCOG Laser Safety Task Group. I've been the chair of it for a few years now. And I was asked to give a presentation on construction laser safety. So next slide. So I'll give you a basic on the background of lasers themselves before we get into the meat and potatoes. But what is a laser? Laser is really an acronym, stands for light amplification for the stimulated emission of radiation. And they're all around us. They've been exploding. I got into lasers in 1991, and there was nowhere near what lasers are being used for as we see nowadays. So, you know, your basic cosmetology, tattoo removal, hair removal, they're using dentistry, your CDs, laser cutting and welding are all your typical ones. LiDAR is a big one now, both in studies, archaeology and such, and also LiDAR being used in autonomous vehicles moving that way. So that's a big field that's Yeah. Can you hear me? Oh, I'm echoing through somebody.
It sounds like some challenging connections here, folks. Our apologies. We'll see if we can try to remedy that. Jamie, yeah, we can hear you if you can continue.
Okay. All right. So they're used all over the place. Next slide. And so basically, the thing that makes lasers special from regular incoherent light sources are the three properties. Monochromatic, which means that if there's a single wavelength or a very discrete band of wavelengths that come out of the laser. So when we talk like a green laser, we'll talk 532 nanometers. An infrared laser, typically a YAG laser used in industry, would be 1064 nanometers. The lasers themselves are directional, which means there's a very low divergence. And so we can look at that when we did the moon missions. We put a retroreflector on the moon. And so a laser that starts out on the Earth, 250,000 miles away, the divergence keeps that laser beam so it only spreads out to about 3 miles wide on the surface of the moon. So that shows you how tightly the divergence is on these things. And then lastly, coherence. That's what gives a laser its oomph. So all of the photons are in step or in phase with one another. Next. And then all lasers have basically three components, from your laser pointer up to where I work, the National Ignition Facility, the world's largest laser. They all have the same basic three components. You have a lasing medium, and that can be a solid, liquid, gas, or a semiconductor. That contains the doped material that's inside there. An excitation mechanism, that would be what you need to excite those atoms inside the lasing medium. And that could be a light source like a flash lamp. You could use another laser. You could use electricity or chemicals. And then you need something to basically bounce those photons back and forth, so a lasing cavity. And so one of your mirrors would be 100% reflective, and then your other mirror on this one would be the right side, would be your output coupler, your partially reflective mirror. And so your photons build up inside there, and then you let some out. That's typically the way a laser works. Next. So lasers are classified from class 1 to 4, and this is in the ANSI Z136, so we're going off the 2014 standard, which is the most recent. The higher the output, the higher the classification. In this chart, you can see that the lower class lasers from class 1 up to class 3B only cover a very small portion of the entirety of the classification system. And this, I've only gone out to 1,000,000 watts, but class 4 goes out to as high an output laser that we can possibly build. And because of that, I've been pushing for another laser classification, would be a class 5, and that would be a laser that would be immediately dangerous to life and health, a type of laser that could cut you in half, or those types of things. Because the class 4, a lot of the rules and regulations out there just don't cover these super high output lasers. Next. And then for detailed classification, so your class 1, your M's mean magnification. That would be a large beam or a fiber optic where you're using a magnifier to look at the beam. And so the class 1 or 1M, that would be typically an enclosed laser that you don't have access to, or a laser that's only a few microwatts. And that would be your data communication lines. A lot of your internet connections that come into homes are fiber optic. Your 2s and 2Ms, those are less than a milliwatt, and they're in the visible portion of the spectrum. They have to be visible because your protection is a blink response. Class 3R, what we're going to talk about today, so it used to be called class 3A, now changed to 3R. We're working with the international standards, and that was basically a power output classification that was carved out for construction lasers primarily back in the day. And their output is, and this is talking general terms for visible, 1 to 5 milliwatts. We get into some little nuances when we work with invisible, but this is just general rule of thumb. Class 3B would be outputs between the 5 milliwatts up to a half a watt, or an output less than 125 millijoules for pulse systems. And these are intrabeam, which means direct exposure, and a speculative reflection exposure hazard. And then your highest output would be the class 4s, and that's higher than a half a watt. It's an interbeam, a diffuse reflection, and it's also can start a fire. So those are your dangerous lasers. Next. And so, why are we concerned about lasers? So in the Department of Energy, I work on the West Coast, so we have the Lawrence Livermore National Laboratory, Stanford Linear Accelerator Center, and Lawrence Berkeley National Laboratory, all really close to each other. So I've put our big laser systems. On the top left, that's the Bella laser for Lawrence Berkeley National Laboratory. It's a petawatt class laser. You do high energy density physics research on it. The bottom center image is the Stanford Linear Accelerator Center, and they have the highest powered X-ray laser that they're using there, again, for this high energy density physics. And then up on the top right is the National Ignition Facility, which is the world's largest, most energetic laser, and it is the size of a sports stadium. And besides those three, we also, the DOE is involved in this thing, LaserNet US, which involves all of the petawatt laser facilities around the country at the universities, trying to increase use across getting us back up to the international standard. And then I just put in a laser pointer and then some optics on the bottom. And that's because we utilize pretty much everything from the pointers all the way up to when you walk into a laser laboratory where you're looking at thousands of optics on an optical table. So we're using lasers for pretty much anything that you can think of, cutting and welding, these high energy density physics lasers, all kinds of different research is going on with lasers around the DOE. Next. And so our regulation is the Z136.1. It's a 2014 standard. It provides a recommendation for the safe use of lasers between 180 nanometers and a millimeter. It gives the guidance for these lasers in the systems, and it's accomplished by classifying the lasers and the systems, and then we basically take our relative hazards based on that. And for the 3Bs and the class 4 lasers, they require a laser safety officer. Next. And so the regulations, so we comply with the Z136.1 with our laser safety task group and the FCOG. There's a Z136.8 that's out for the safe use of lasers in research and development. The initial standard came out a few years ago, and we didn't feel it was quite ready for prime time, so we use it as a best practice because there was some conflicting between the .1 and the .8, but we feel that once the new .8 comes out, which is very soon, and a new .1 is coming out also, so when they come out, some of the R&D labs may move over to the .8 standard. Oversight of construction lasers is by industrial safety and IH personnel, and really we're looking for lasers greater than 3R. Most all the lasers that they use in construction are the 3R, and we'll talk about that in a little bit. Construction lasers are sold in the U.S. to comply with the Federal Laser Product Performance Standards, or FLIPS, that's under the FDA. And lasers that are class 3B and 4 aren't authorized to be operated on a construction site. They would need special approval in order to operate that, because when you're talking about construction sites, most of them are outdoor, and generally, again, I mentioned that the class 3R was carved out for that. So construction lasers are covered under OSHA under 29 CFR 1926 subpart D and .54, and that's where the non-ionizing radiations are in. So it just talks about what the construction site has to comply with for them to do work at their sites. Next. And so here you see a bunch of different typical kinds of construction lasers. Anything from, you've got things that'll measure distance. So back in the old days, they used to just have, basically it was levelers. And you can get these at your Home Depots, your Lowe's, your big box stores, where if you're doing construction in your house, you can lay a nice line, as you can see in the bottom right down there, on your wall if you're putting boards up or different things, you can make them nice and level. That's what they really started out with. The top one, you can see it's a rotating one, and so it'll put spots so they can put walls up even. You've got different things for laying pipe. The one on the right is your LiDAR type of laser. Those are kind of neat because they're invisible lasers. Now they will put out a visible alignment light so you can see where you're starting out at. But a laser like that you can take very detailed measurements down to a micron, and we use those in the NIF to measure the settling of the building or components in regards to target chamber center. So we're looking at very, very low tolerances. And so if you look at this, there's and it keeps expanding, but these things are all in the class 3 area or lower. It could be class 1. Next. And so here I just showed a few different construction sites where you would have lasers. The left is when they built the NIF, very large construction site. Again, you're controlling the construction site. You have to cross through to get in at some point. So there's a lot of lasers used in that. You can see simplified ones that are used in most construction sites are your ones to lay lines on walls, to measure, to make sure things are level. And the LiDAR type that I mentioned is on the bottom right side, and that's where you're getting your detailed images measuring things so that you can lay things out to specific points. And the sign that you would see on a construction site would typically be the caution sign right here with a class. We still put the class 3A, 3R because you find a lot of lasers that are still being sold under the old class 3A designation, but hopefully eventually in the future they'll phase out and we'll have just strictly 3R. Next. And so basically for training and regulations, regulations require that all 3 Bs and class 4 operators of lasers, they shall be trained. The DOE National Training Center and the FCOG Laser Safety Task Group, we developed a web-based laser worker training course, which is used across the complex, and it really helps us because we do reciprocity, makes it easier when we're traveling users from site to site. And then there's local training, which includes site-specific, lessons learned, different types of alignment training, and OJT. And there's like 4 national laboratories, I think, right now that have a hands-on practical alignment training. Industrial safety professionals are trained to monitor the construction sites at the DOE facilities, right? So they're out looking for these types of things. Many of the DOE labs have permanent members on the Z136 Standards Committee. Los Alamos, Lawrence Berkeley, Lawrence Livermore, and SLAC all have permanent seats on the committee. So we help establish the industry standards and the next revisions out in 2021. Next. And so how hazardous are laser users used in construction? So I put this up there. Basically, the one on the left, the laser pointer, and the one on the right, they're both class 3R lasers. They are 5 milliwatts or less. And so when you look on the classification scheme, they're down there in that little bunched up area. And again, it was carved out for construction. Class 2 used to be what laser pointers were, and somehow laser pointers have squeezed themselves into the class 3R area. Next. And so finally, key points for safety professionals, right? All lasers are regulated by the FDA. Class 2, 3R, 3Bs, and 4s, they required to have a visible classification label on them. And this is really concerning in laser pointers sometimes because they'll come in the box, they won't be stuck on the laser, and they get tossed out. Construction lasers fall under 29 CFR 1926.54. Construction site managers are responsible for any control measures, so the control of the site, any of the training of their workers, the signage, and one big thing is not directing their laser beams into roads or occupied spaces. That might be something that would raise some concern if, especially if they're doing work on a road and see some flashing laser light coming down the road as you're driving up. So as with laser pointers, there may be mislabeled lasers, but this is pretty much a rarity in the field of construction only because of the high requirements for tolerances and such. But there is issues with mislabeled laser pointers that you need to be aware of. If you in a conference room, you're looking at a board, somebody's using a laser pointer and it's too bright to look at, it's probably over the limit. And I confiscate many of these all the time because it's a very loose controlled out there for pointers. So if you notice in laser operation, whether it's a conference room, construction site or something, if the light's unbearably bright, you want to contact your laser safety officer or whoever you're using for, if you don't have one for your site because you don't have a class 3B or 4, your industrial hygiene, industrial safety, or health physics personnel to take a look at this. And I believe that's it.
Great. All right, Jamie, thank you so much for the presentation. It was very, Very educational. We appreciate it.
Okay.
We will ask you, Jamie, if you could hold on to the end as we're going to transition to our other speaker. Actually, before that, though, I think I'd like to turn it over to Mr. Maurice Haygood. Maurice, are you online with us? Hello, Maurice.
Yeah, Joe, can you hear me?
I can, sir. The floor is yours.
Okay. All right, just making sure we were having some comms issues earlier. Yeah, good afternoon, everyone. And on behalf of AU11, I would like to extend our regards and say thanks for everyone to attending the WebEx. We've got a great presenter coming up for you, and that's Bill Schleyer. He's a certified safety professional with over 30 years of experience. I've had the pleasure of working with Bill for the past 14 months, and I've benefited from that greatly and have learned a lot. Bill is the newly appointed chairperson for the Hoisting and Rigging Technical Advisory Committee, and within that 4 months, we've actually accomplished a number of things, to include the publishing of the DOE's Technical Standard 1090, which is the hoisting and rigging standard, and reclamation and expansion of our membership to the advisory committee through Bill's what he calls and what he's deemed as the Restart Initiative. So I've said a lot, and he's going to talk more about fall zones and danger zones, and so I'm going to turn it over to Bill and let him go forward. Bill?
All right, I got off mute. I'm going to have to set my screen so that I can display mine. I already have that, so give me a second while I change the screen, because I'm going to drive this boat myself this time. It's just a little easier for me.
No problem, Bill. You have control. It should be all yours. Thank you, sir.
All righty, well, first, this is amazing. I see on the head count that there are 225 plus people at one of these meetings, and this shows the value of sharing as a community of practice for safety. And I know it's all because Jamie was there talking lasers, but I'll take any overflow from that too. I've been with the NNSA now for 15, 16 years and been involved with writing 851, many different activities, safety culture improvement panel, and now with the Hoisting and Rigging Committee. And when we were talking with AU11 about what could be shared, the concepts of fall zone and danger zone came across the table, and this presentation was put together probably in the last month. It's a consolidation of efforts from the private sector, what some of the site hoisting and rigging subject matter experts provided, and what I provided to link it all into ISMS. This is the first time it's been given, so feel free to say this is right, this is wrong, or I'd be interested to know what else we need to address. This is a sharing, this is advisory, this is an awareness level presentation. It has no intent at all to read the regs to anybody or really focus on compliance. This is about safety to protect workers. So that's what we're trying to do. But before we talk the safety part, I want to talk to you about what the DOE Hoisting Rigging Advisory Committee is.
Bill, I'm sorry to interrupt you, sir. Can you share your screen? Because I don't think our audience is seeing your slides, sir.
Oh, I thought I did. So let's try it again.
There we go.
You said I was good to go. I thought you told me you saw it. All right.
I apologize, Bill. There you go.
So we're at the perfect place to share screens. Thanks, Joe.
No problem.
This is presented to DOE, and I'm using the DOE Hoisting and Rigging Committee as that group of people that brought it together and is sharing with you for that awareness. So it's two sections. One is a hoisting and rigging, and one is the danger zone. So we're introducing you to the Hoisting and Rigging Advisory Committee. We're talking to you about what issues we're going to tackle, and then we're getting into one of our issues, and that's danger fall zone. I hope you can see this on the screen. I will read more than I'd like to, but I know there are folks connected on the phone, so bear with us. I know Joe will make sure this is available. But the example picture just shows that this is a risk where people can have things dropped on them. So what is a Hoisting and Rigging Advisory Committee? It is a group of volunteers who have offered their time to participate by sharing their experiences with hoisting and rigging, cranes, lifting, forklifts, material handling, just the whole spectrum of taking an item that has a mass to it and has potential energy and moving it somewhere else. This committee is chartered by AU10, the Office of EHSS, of which Jim Dillard and Joe Dobbins are participants, as many of the others as all the others that you saw when Joe introduced the group. Okay, we provide advice to the DOE through our sponsor, Maurice Haygood. This committee doesn't have the authorities or responsibilities to just change the orders, tell you what to do, but we can bring that experience gained from the field and provide awareness that you can use at your sites. We help maintain the 1090 standard for hoisting and rigging, and congrats to all that provided inputs to that. It was just published in July, so that's pretty new on the streets. As I said, we recommend practices for safe performance to the DOE. And just remember that the technical standard is not a mandatory practice. It's best management practices that when used, the DOE gives you credit for, is they're trying to do business the right way. So this group of people, of which we're like 60, meet every 2 to 3 months and contribute to sharing the knowledge about hoisting and rigging. There's a history of accidents in the DOE as in the public sector, so hoisting and rigging is a real risk. And the 60 people we have, plus or minus, on this committee are dedicated to reducing that number of injuries, number of drops, mission impacts. And we do that by collectively working on issues that we feel are important. We collaborate through sharing of examples and operations and processes, so everybody gets information that can help them do their job. And something I think is really important about this committee, and you heard it from James with the lasers, we have competent people that participate on national consensus standards committees, the ASME B30.2 for overhead cranes and gantry subcommittee, the B30.15 for cranes and monorails. These are just a few of them. It's just a highlight to the folks in DOE that take their skills and abilities and reach out broader than just their sites, trying to improve hoisting and rigging across the complex. Now, what is the complex? Everybody talks about the complex, the enterprise, our partnerships. Well, this slide gives a map with little blocks on a map to show you where we are, and you can see it's across the entire country, far west coast to far east coast. On the right, there's a list. Take a look at that, see where you fit in. So what are we working on? The Hoisting and Rigging Committee met and started or restarted this group, one, because we had change in leadership, change in people who were in the committee, and it kind of went dormant, because that's what committees do when we don't keep pushing toward achieving something. People have other jobs and they tend to drift away. We're trying to get all back together, and in this get back together, we polled everybody in the community and said, what are issues that affect your sites and affect hoisting and rigging? On the screen, I have a few of them, but we got like 30 plus issues, and we sorted these by major functions, and then we rank them by the major functions as well as the individual issues. And these are just some of the highlights of what we're working on. We're going to be working on, on training. Training's a broad topic. It's really how do we improve the competency of people across the enterprise and have sustainability, so when the older people who have met their career goals and decide it's time to move on or retire, we have folks ready and willing to come behind them and keep emphasis on hoisting and rigging. We want to improve operations by sharing among sites. Every site does similar things. Some have been vetted that work better than others, and the more we share, the more consistency we have in expectations for safe performance and methods to achieve that safe performance. And part of the operations look we're going to do is what can we do on the front end of lifting that will preset the conditions so people know going into that lift what are the best things to do that are going to be most likely to drive a safe performance at the end. I talked about committee being restarted. Our committee also has a section as far as our issues of how are we going to manage the committee? How are we going to get engagement? What are we going to work on? Track it, project management, all those things you expect a committee to support so the workers in the field can better focus their time on solving the issues. So those are the major issues we're working on. And I'm probably going to talk too fast trying to get through so we have open time for discussion. And I'm serious. If there are comments, ideas, share them with us and we'll put them to work or judge how we can put them in our risk profiles. So here's what you need to know. One, how do you reach out and connect with the hoisting and rigging professionals on your site? As a safety person, which is hopefully what we all are, and if you're not a direct safety person, even more attaboys and girls to you for joining this so you can see what our safety professionals do. But reach out and connect with the hoisting and rigging experts at your site so you know who they are and know when to go to them so accidents that happen, such as most recently out in Nevada, are less likely to occur because you seek the expertise right away and you know who to seek that through. And then the other one is, how can you participate within your site in the safety activities associated with hoisting and rigging? And whether or not you want to participate with this committee, you're more than welcome. We love people who are willing to contribute time and energy, but you need to know how to function at your own site. So that's my political stand right now for what the committee does and where you can participate for safety and hoisting and rigging at your site. So let's jump over to why you probably really came, something new and different. Fall zone and danger zone. All righty, so you got the message. It's out there, the danger zone and the fall zone. And I again thank the DOE and private sector contributors who contributed this content. That said, all the graphics, all the displays and everything you blame on me because I don't have a Lawrence Livermore IT department to help out or a communications department to help out. So bear with me as we run through this, but I hope some of these things catch your attention and you remember them as awareness. So one, we lift frequently in tight spaces with ordinary, special, production, and critical lifts across the whole DOE enterprise. And our workers and our materials are always at risk. These are two examples. If you have driven through your sites and looked out the windows, you have probably seen big cranes, big trucks having big loads lifted off them, small loads being lifted off of them, and any number of material handling using forklifts or other devices to lift loads. So you should recognize that this is material to what we do and increase your awareness through this presentation that we have to manage it well. So I'm going to just talk about practices here. These aren't requirements. They're not in directives and guides. This is not the absolute only way to do it. This is to drive your thinking about how we can make hoisting and rigging better. So why is it important? People are dying. Sure, people die all the time, but we don't want them dying on our site from lifting accidents that we have some control over. And it's a greater number of hazards than we have accidents, but we do know that there are more accidents related to lifting than there are many other activities in the DOE where we put considerable energies. So I'm saying if you have energy toward a certain subject and the risk isn't as great, balance your energy use into managing some of the higher risk, of which one of these is hoisting and rigging. So I have on the slide some examples of where we've had real hazards and real accidents. I was on a DOE Llano Accident Investigation Board where we had a serious injury resulting from a mishap using lifting equipment to move heavy pieces of metal. We've had forklifts drop from elevations, HVAC systems. We've had reactor elements fall. We've had lifting point failures where items where you attach a strap, break, and suddenly the load is free and dangling or falling. If you look at the occupational injury results, over the last 5 years, we've had 44 people a year killed with crane-related deaths, and that's just crane-related. So I hope you can feel the need to put attention into this fall zone and danger zone activities. It's a real hazard. So what are they? OSHA defines in 1926.1401 a fall zone as that area, including but not limited to that area directly beneath the load, in which it is reasonably foreseeable that partially or completely suspended materials could fall in the event of an accident. The words fall zone meaning what happens when something falls directly is more evident, but when we start talking about the included but not limited to the area directly beneath the load, we expand beyond just the vertical drop of a load to associated energies with that fall. So that's why the term danger zone was crafted. It's not in a standard. It's an expression for this presentation, and it's used in the private sector to increasing extent to say, think bigger than just below the load, because it is reasonably foreseeable that energies are released, whether the crane falls, whether straps break, whether a lifted load hits something else and that falls. So we want to make the awareness that this danger is a term of warning that everybody pays attention to associated with the load. It's not one of those things that people just inherently know this is dangerous. So we're going to make sure, and this presentation is going to help that, provide methods that we can keep people aware. So danger is a warning term. You've seen it. In the radiation protection world, there's danger, high contamination area. There's danger lasers. There's danger all over, but the word danger is that trigger word to get your emotional awareness. And it's an emotional awareness because of a hazardous condition where a scenario can lead to harm. Just because something's heavy doesn't mean it's harmful. If it's heavy and lifted where it can move through a scenario and harm people, we need to increase awareness to that. Again, danger zone is not an OSHA term, but we're going to talk to it as if it's a visual representation of areas where energies can hurt people. OSHA uses the term dangerous area in some of their standards in 1926-143, strictly talking about crane operations. But we want to take that past strictly crane operations and bring it to the community of lifting. So keep that in mind. Danger zone is to capture workers' attention so that people are aware and actually start thinking about the hazards. Sites often have different warning terms. Use and teach to what applies to your site. Adjust those as you need to stay current with best practices. But in the context of this presentation, a danger zone is any area location potentially impacted by failures or events during the life cycle of a list. You won't find our term life cycle probably, but that's the term we use in a lot of in our processes, in our project management, in our construction. Life cycle means when we thought about it at the beginning and we want to do something, through the whole process of doing it, and closure at the end when it's all done, which would include feedback and improvement. All right? So think holistically about this lift. And we want to control those hazards and warn of the dangers. So that's the definition of what danger zone really is as we use it. Now, this is a depiction I've seen at other sites very precise graphics that define what a fall zone is. 45 degrees from the bottom of the load out to wherever the load might fall. Suffice it to say that this doesn't work, because if you're lifting a load and it's 200 feet up in the air and you go 45 degrees from that load, suddenly no one can be on the site. So we need to be realistic and plan for managing the fall zone using what we know about energies, the physics, the equipment, and everything else. But typically a load will fall, and if it moves sideways, gravity is going to cause it to turn, and sooner or later it's going to be falling almost straight down. So make sure your mental pictures that you teach to match somewhat reality, and you explain people how that reality works. The fall zone is set by the risk owners, the risk acceptance authorities. And that's often done through processes and procedures that flow down to those qualified hoisting and rigging workers, so they can say, for this lift, this is what we want to deal with the fall zone and the incorporated danger zone. It's very lift dependent, and it's not a mathematical equation, so it takes professional expertise. And the hoisting and rigging subject matter experts at your site have spent years learning their subject the way you learn your subject, and they are able to make these decisions or recommendations to a risk accepting official. As with anything else, we need to be prepared to expect the unexpected. If nothing ever broke, if winds never came up, if ice never occurred, these would be simple decisions. But we need to prepare by defining the fall zone, describing the danger zone, and working to manage the unexpected. So how do we plan to address the fall zone danger zone? And we want to apply thoroughly integrated safety management systems and the concepts of work planning and control. If your site uses ISO 45001 or OSHAS, we're talking the same thing. Know what you have, plan through it, and apply the principles that make work safe. So you start with that untrained users are probably unaware of what it means to be exposed to the danger zone or the fall zone, the not limited to but directly below the load. And it is work planning and control practices that make all users aware. Don't erroneously focus strictly on the load and where it falls down, but think broader. So the key point is on setting the mindset for danger and fall zones. It's building that awareness of the potentially deadly consequences of the fall zone and where releases of energy exceed just vertically below the load, because often as not, those can result in injuries and death. So set the mindset to your workers that it's bigger than just below the load, and it can be from many, many different energy releases. So I mentioned ISMS. I've read the other safety management standards, and I am firmly committed that if we apply the principles of integrated safety management to how we think through and plan through work, we can build safety systems or safety controls for that work that are sound. Okay, I know if you walk on a site and ask somebody, what does ISMS mean? They're going to talk the circle. Plan, do, check, act. While important, that is a process. It's applying the principles during that process and during your work planning that really make the difference. And you can read them on the screen. You probably know them all by heart. Line management responsibility, clear roles and responsibilities, competency commensurate with those responsibilities, balanced priorities, identification of safety standards, which invokes all the ASME standards, OSHA, the standards you set at your own site become standards for ISMS. And then making controls that really match the work you're doing so that we do good safety and still able to have safe performance to achieve our mission. and operations authorization. So those principles are applied here. In the processes at the sites, that we do this on a planned basis to achieve work planning and control, and we use the site's lifting and planning processes that will incorporate this fall zone and danger zone. We want to evaluate the sphere of influence, which is that entire space around that load where these energies could be released and hurt somebody. And I say energies loosely. If you drop a 55-gallon drum of hydrochloric acid and it breaks, it's part of that fall, and that energy can hurt you. So we need to plan that the lift doesn't drop a 55-gallon drum of anything. I listed energy trace barrier analysis as a tool as a way to help plan. That is one of many, many different analysis tools that structure how you think through processes. You can look that up. System Safety has it. The DOE's accident investigation protocols and standards on the DOE site can talk to you about it. And we want to do this with the concept of as low as reasonably achievable or reasonably practicable or as low as reasonable. But the point is, we go to the extreme to make sure we're doing all we can do to reduce risk in a manner that we can actually do the work safely without extra influences. As low as reasonable is a judgment call. That's why line management has responsibility and competent people weigh in on it. But the point here is we do it well. Other factors in controlling and planning lists would be the communication aspects. After you do the planning, if you don't communicate it thoroughly top to bottom and make sure people have that in their mindset when they start work, all the planning's for naught. So do those pre-jobs to increase understanding. Use real world, prototype, demonstrate, discuss, ask questions, but make sure we communicate what has to be done and do that after we've had good authorization to do the lifts. So, okay, we talk planning. It's necessary, but how do you plan? I'm going to hit some factors that we can use in fall planning. They're by no manner inclusive of everything you'd ever do, but they're fundamentals. And at your site, ask the questions, do the work to figure out what really matters for you to do your site. And just remember, if you can't recognize what the hazard is, you really can't control that load, its potential fall, or any released energy. And this is where the subject matter expertise of the hoisting and rigging folks and those workers who've spent years out there doing construction and research load lifting, like to build that, the NIF or any other facilities, they have experience that all have to contribute to analyzing and evaluating the factors of a fall zone and a danger zone. The picture I just popped up is just a commercial workplace where you see a guy standing on the top of a staircase ladder set, and he's under a load, and it's a big load, and this is just a reminder to us as feds that the private sector does things their way, and hopefully they're doing safely, but we're going to be better, and some of these techniques I'm going to talk to can apply to help us do it better. You'll have more. Please send them to me by email or whatever talk at the end, because we want to start capturing these as best management practices. So here are some factors in defining what that fall zone is and the danger zone. One, we're going to look at the sphere of influence. That is the 360 sphere, 4 pi r around whatever that load is, that says, here's where we need to be paying attention. And if you don't look in that space, you won't recognize the hazards that could happen in that space. So look in every direction, and that means up as well as down. There's a tendency for us to look down, but if you're doing lifting and you're anywhere where there's overhead materials, overhead power lines, overhead equipment, you have to consider that in the management of your fall zone, because it may not be directly under the load itself, but it could cause something to fall into that load or cause that load to fall. anyway, there are many options for energy release, and get your experts out there together and think through it. On the right-hand side of this slide, I have just some factors to consider. You can read them. You can ask within your hoisting and rigging group how these apply, but some of them I'm going to highlight. This is predict and analyze. This is the thinking part of work planning and control. Use your riggers to know how it's going to be rigged and the whole process of setting up to do the lift well. It's not often that the lift cables on a crane break. It's that the crane falls or the load shifts and comes off the hook or whatever, but that's the rigging that we have most intimate control over and need to think through. So you can see there's attachment points, how you attach it. How do we unhook after a load's done? Because the load isn't done until we finish that whole life cycle and put all the tools away and done the critique. And if we unhook in the wrong order, the wrong way, and the load shifts, it's just as dangerous as if it fell. Another one I think is really important is this projectile recoil and the release tension that comes with anything that's put under tension when you lift it. So take a look at those and see how they can apply when you do your safety oversight, when you do your safety planning, or you do your load liftings. All right, so here's something else that's really interesting just to show you about recoil and tension. And some of you probably seen this before, but this is a video of a synthetic line snapback that's put under loads. Well, so that's real, isn't it? We've seen that happen. Even today, when we buy hoisting and rigging equipment, we purchase it from manufacturers who test it to failure, and they can show you videos for the equipment you use of what happens when a hoisting and rigging attachment, a below the hook attachment, straps, anything fails. So it's a true visualization that energy can hurt you. These were provided to me, and I'd never seen them before. I started putting this class together, but they're very clear and visual representations of what the danger is. Never on a load, never under a load, never in line with the load equipment. If it failed, it could hit you. And then in just material handling for trucks and lifts, never on top of the load if you're standing in a truck or on any subject or device as far as that goes. Never get under load, so you'll be away from a fall. Never get between something hard and the item that can fall where you can get crushed. So those are just some visualizations that you might be able to put in your memory or apply at your site. Okay, so we're going to get into a little more detail in evaluating the sphere of influence. And I have an example word up there, but just consider you're using a spreader bar that is a metal beam that puts your hooks almost vertical under the spreader beam so you can pick it in, say, the middle and attach hooks on the outside. If one hook side fails, that whole load wants to shift. It's kind of like this. And then it's going to swing. So that's just an example of where you want to not be in that danger zone when it wants to swing and move. And now we're going to talk about defining controls. We've looked at the processes, we've looked at the activities and the factors. Now you need to apply those factors in actually developing a control set. So we want to, with the workers and the subject matter experts and the leadership using ISMS, set the controls, or really define the safety expectations. OSHA has some specifics, but it doesn't, the OSHA is never going to keep up with what we do. We apply OSHA, but we're looking for other activities that are somewhat unique to us that we can also manage to that higher level. So on the left side, the OSHA says OSHA, in this case, ASME, not OSHA, we've said in B30.9 that the consensus standard for the U.S. is personnel shall not pass under or stand under a suspended load. Another ASME standard statement is personnel should not stand in line or next to slings under tension. You just saw that in the example. You saw it in the little diagrams. So what we want to do is keep everyone out of the keep everyone out of the fall zone, which is the below the zone areas where it could reasonably fall. We clearly want to plan in when a qualified person is allowed to be in the fall zone. We recognize that not all work can be done without ever having a person under the load. So when it's absolutely necessary to have a person under the load, we have to put additional considerations there and plan that. And when we have a requirement to put somebody under the load by the work, we use people who are assigned that job, who have the competencies, who know and understand the specific functions they're supposed to do and what actions. And we want to limit that temporary exposure to the shortest time possible. Same thing with any other safety. Competent people knowing exactly what they're doing and minimize their exposure. So once again, the little ideograms of not on the load, not under the load, never in line with the load. Those should help drive your thought process. Mentioned earlier about 1926, 142 in OSHA about cranes and derricks. Again, it says hoisting routes minimize employee exposure. When you lift the load and have to move it through rotating a crane or a boom on a crane, that whole path of motion now becomes part of the fall zone and part of the danger zone. So we manage those by understanding that path and applying the OSHA specifics to the qualified riggers and using the equipment OSHA says you have to do, such as self-closing hooks. And I know I'm being repetitive here, but that way you'll remember it. So again, 1926 OSHA construction standard for 1425 is keeping clear of the load. It says that the regulations detail the requirements and provide good guidance. And in summary, it's avoid carrying loads over people, so you plan the path. When the suspended load is not moving and there's no reason to be under it, don't be, but it's necessary on a non-moving load to have a person under it for hooking or unhooking or whatever other attachments you have to be. Have those people under the load only for the shortest time and that they're qualified. OSHA 1926, 1425 also says the load must be rigged to prevent unintentional displacement. And that word rigged is pretty specific if you look at our DOE hoisting and rigging standard and what the ASME standards are that are used at the site. Rigging is not accidental. It's a planned, calculated, engineered activity so we can avoid the unintentional displacements. We want to use hooks that stay on their load, so we use self-closing hooks or equivalents. And we want all this done by a qualified rigger. Your hoisting and rigging key people on your site are qualified by the true definition of OSHA being qualified in that they're trained and experienced and authorized to do that work. When we land the load, we want to make sure the employees that are landing the load stay out of the fall zone but we need to be aware that they still are in the danger zone and have to manage it. Tilt up, tilt down operations such as moving walls up on a building have special aspects that have to be considered. It's not all lift the heavy load straight under a hook. There's a lot of motion there, and we have to be aware of all of it. So what are some of the safety controls you could include? And these are the ones that meet OSHA. Define rigging material, set engineering controls, such as fixtures and tables and lifting beams that make that lift more engineered and less subject to human error. Do these lifts as much as you can from a distance, such as in OSHA 1926-1424, where we use control lines to manage the load. We put up warning lines and barriers and railings to keep everybody else out of the way. We use alignment guides so that when we do connect loads to below the hook lifting devices, that it aligns easily, that there's no need to do anything out of the ordinary to connect the load. It's well planned and thought out. And we do as much as we can for attachment remotely or from a distance, but we recognize there's times when people have to be on that load or at that load. You can be at the load by getting on another platform or some device, so you don't have to necessarily be on the load itself. And when we manage these loads, we want to control all the lateral forces that make it swing, that make it bounce, that might make it bounce and break and then swing in another way. And we really want to try hard to eliminate any rapidly released energy, using devices that when they fail, they tend to fail more safely than become that rocket projectile synthetic rope like we saw in the video. And we definitely want to evaluate where a fall could happen and drive management of that area. Plan as if it will fall, so we'll be prepared that if it does fall, we'll be safe. Here is a picture of the level of detail that often gets done when we're planning critical loads. This is a mock-up. I've been on critical lifts where we've taken 60-foot overhead walkways that span two buildings and bring in a crane and lower it down to the ground during D&D projects. So this might be more simplified, but it does represent that the level of planning we have access to with computers, the tool sites have for hoisting and rigging, that we can actually do some thorough thought processes, especially for those loads that are most dangerous, so we're less likely to have a drop and hurt somebody. This is an overhead view showing that that sphere of influence has to be applied throughout the path of motion for that load. It's just a reminder, the sphere of influence is broader than the directly fall zone and anything that could potentially happen under that load. So, kind of like as a highlight, hoisting and rigging is definitely hazardous. And with the hoisting and rigging crews we have on the sites, the processes and procedures we have for doing lift planning, we can do lifts well. We can do them in a controlled manner to manage the risk, and we can set the conditions for safe performance. So the key to this is work the lift plan, and working the lift plan will include that fall zone and that concept of a danger zone. So, Joe, that's the end of the presentation, and I'm open to questions after everybody asks questions about laser safety. So I'm going to turn the screen back to you.
Thank you, Bill. We really appreciate your presentation, and we will end our recording session. Don't anybody go away. It's just we will end.